This is Ray's Magnetic Battery Part 3. I'm going to be showing magnets if they have any bearing on the flow of electricity going through the ground. I have set up quarters, copper strips, and galvanized nails. They are all the same material. Therefore, the difference in voltage between the two quarters, the two strips of copper, and the two strips of nails, they should be close to 0 volts. They'll float a little bit, but they'll somewhere towards that end. We'll start off with the two quarters. Being of the same material, the voltage difference between them should be very low. Okay, 0.005, somewhere in that area. Okay, we're going to go to the next one. I'll write that down. The two quarters, somewhere around 0.05 volts. We're going to go to the copper foil. They also, being of the same type of material, also that should be fairly close to the 0 volts also. .009. I believe that was okay. Now we're going to go to the nails. They are galvanized. I'm going to move the camera so I can get that shot better. They're actually 0 volts. Let's see what happens when we have unlike metals. Because they're different metals, there is a voltage that is set up between them. We'll go copper and the galvanized nail. We have even up to 0.8 volts, 0.9. Okay, that floats back and forth. Okay, I was doing that so I would demonstrate. The magnets are 1/8 by 1/2 neos. They're being of the same material also. They would also be close to the 0 voltage. Let's see what happens. If they were unlike materials, I could see where there would be a voltage set up between the difference of materials, but these are the same, then they should be close to 0. We have north and a south. They are unlike poles. Yeah, we're going to go 0.005 minus voltage. We're going to have them both the same fields. North is up now. Okay, see what happens. You see an extraordinary difference. Now that'll come down some because it's being loaded down by the current. But we had 0.09, close to a volt, or I mean tenth of a volt. Okay. It started out, this was same poles, 0.09. It dropped down to 0.06, and it will come down further. But you can see the difference. It went from a negative reading to a positive reading. That shows me that the magnetic fields are having some type of effect of the flow of electricity. One way it is accelerating, the other way it is deceleration of the current. Okay? You'll find mixed readings on these things when we turn them over. We're working opposite of what was charged in there. The battery of the earth itself seems to be somewhat like a car battery. It'll hold a charge, so your readings do float around quite a bit. But if you wait several minutes in between, then that's better. Let's see what's happening. You see, it did not go up to 0.09, and it's dropping pretty fast. Like I said, it was charged a little bit, so we had that residue charge left over. But you can see how it's going to float down there, and it'll finally get down to that 0 and even go down to the minus readings. Just to get it down to 0. Okay, we're going to turn it over one more time. Then we're going to have that charge doing a reinforcement. Okay, see that? So it's a positive reading, and it's holding a little bit better. Like I say, the earth seems to work like a battery. It holds the charge a little bit. But you can see the great discrepancy between if the poles are the same or the poles are different. So I hope you like this. I hope you work on this. Have a lot of fun. You may discover something very important. Thanks for watching.